All right, guys, so let's continue on with these power series. And remember, we know we have a power series because we have that x in there that kind of creates the polynomial. Um, this time, notice we're centered at 2. Okay, I have an a value there, so I'm actually centered at 2. It's not just x, it's x minus 2, so I'm centered at 2. Centered at 2. What else? We're going to find the radius of convergence and the interval. Okay, remember that if it's a power series, it converges. Okay, so we got 3 more to go through. What happens if it's not centered at 0? So the first 4 were centered at 0. This one's going to be centered at 2. But we still do the ratio test. Everything is pretty much the same. We're going to do the limit as n approaches infinity of x minus 2 to the n plus 1 over n plus 1 squared plus 1, and then divided by x minus 2 to the n over n squared plus 1. Okay, and then same thing holds true. Instead of dividing, we're going to multiply by the reciprocal. So we have x minus 2 to the n times x minus 2 to the first. We'll split that up over, this is going to have to stay, right? N plus 1 squared plus 1, and then times n squared plus 1 over n minus 2 to the n. Okay. All right, so not a lot cancels here. I think this is the only thing that's going to actually cancel. Okay, this though, we could write this out twice, n plus 1 times n plus 1. That gives us what? N squared plus 2n plus 1 if we FOIL and do outer and inner together. And then don't forget we still have this plus 1. Okay, so let's see, I'm going to slide this up. I think we're good there. The limit as n approaches infinity. On the top, what do we have? We've got x minus 2 over n squared plus 1. And then on the bottom, we just have this guy, right? So we have n squared plus 2n, and then we can at least add those together, plus 2. Okay. How are we doing on space? We could, if we wanted this x, right? This x is not part of the limit, because the limit is as n approaches infinity. So we're looking at n squared plus 1, and then I can put the x minus 2, and then n squared plus 2n plus 2. So we can look at kind of, oops, that's absolute value. We can look at this here, right? Because those have all the n's in them. That limit, these are both n squared, so it's the lead coefficient, 1 over 1. So that's equal to the absolute value technically of 1 over 1 times x minus 2. Okay. So we don't really care about that, the 1 over 1, so we've got x minus, can you guys see? Yep, x minus 2. That's my limit, and the ratios test says this has to be less than 1. Okay, so we'll slide this up. Okay, so this is -1 is less than x minus 2, which is less than 1. That's just how you do absolute value. Let me clarify, that's how you do absolute values when it's less than, all right? When it's greater than, you have to do it as 2 separate ones. You have to do it as an or, but for less than is a little bit nicer to work with. All right, so you added 2 to all places, okay? And so this is going to give us 1 is less than x, which is less than 3. Okay, but remember, okay, so that's my interval. My interval is 1, 3. Got to test the endpoints, of course, right? But I'm centered at 2, which you guys cannot see, right? I am centered at, where was I? I'm centered at 2. So I'm centered at, can you see this? Yes, centered at 2, and I'm going from 1 to 3. So what is my radius? My radius is radius should be 1. Okay, yeah, my radius is 1. I was thinking something else, but all right, so I'm centered at 2, and then I'm going from 1 to 3, so my radius is 1. Okay. All right, so now, and I got my interval, except I have to test the endpoints. Okay, so let's get rid of this. Let's slide, we'll kind of do this side by side, right? So I have to, now this time, what am I plugging in? I'm not plugging in positive and negative. Actually, it's kind of nice, I get to plug in both positives. So let's do when x is 1, okay? And then I'm going to take this, my original problem, and I'm going to plug in a 1 for x, and then everything else stays. Okay. All right, so what happens here? I've got n equals 0 to infinity. This gives me negative 1 to the n. That's kind of nice. So what did I just create? I have an alternating series. So I might as well do the alternating series test. That means I just focus in, let's write that, alternating test. We could just write that. This is n squared plus 1. Okay, so when I put in are my terms getting bigger, or I'm sorry, actually, are my terms getting smaller, right? Each one should get smaller. So when I let n equal, we could start at 0. You know, you can kind of start wherever because it's supposed to cover it for everything. So we're just testing a few here. So that would give me what, 1? When n is 2, I get 1/5. Have we seen this pattern before? When I plug in 3, I get 1/7. All right, when I plug in 4, I get 1/9. So they are in fact getting smaller. So that's I. And then part 2 of the alternating series test. And remember, you could almost kind of jump to this one from the start if you want. What is the limit? And sure enough, the limit, as I put bigger and bigger numbers, this is headed towards 0. Okay, so that means that when x is 1, it does converge. Okay, and so what does that tell me back here? That just tells me that I can put a bracket because it does converge. Okay, now we go one more time. We test 3. So let's slide this up. X equals 3, summation, n equals 0 to infinity. Let's go back and look at the original one. I'm plugging in a 3 minus 2 to the n. Oh, that's kind of nice. They give us at least some nice ones. All right, so that is going to give us, can we see? That's going to give us what? That's just going to give us 1. Maybe I can even write it here. 1 to the n, which we don't really even care about. Okay, so 1 to the 10th is still going to be 1. 1 to the millionth is still going to be 1. So I've got 1 over n squared plus 1. Okay, so now what test? We haven't seen this one for a while. What test are we going to use for this? I'm going to do the comparison test. Comparison test. And my benchmark is going to be kind of when I have n to a power, you're thinking to do that comparison test or limit comparison test. So my benchmark is going to be 1 over n squared. Okay, now this is not harmonic because I have a number there. You know, if it's 1, then it's harmonic. But if there's any other number there besides 1, then it's a p-series. And harmonic is a p-series also, but we usually just call it harmonic. So this is a p-series. My p-value is 2. I don't know if I have it. If it's less than, I'm sorry, if it's greater than 1, then it converges. I thought somewhere I had it, but otherwise just look that up. And again, because that might be something that you're like, I forget. Okay, here it is actually. P-series, look, let's kind of see what that looks like. N to an exponent. All right, if p is greater, it converges if p is greater than 1. Okay. All right, so that converges, but remember I'm doing a benchmark. So my benchmark says if this converges, this has to be true. This, and it has to be for converges. If my benchmark converges, this has to be true. Okay, so we have to kind of take a look, is that actually true? And I think it is, right? If we make the bottom bigger, the overall fraction is going to be smaller. All right, if the bottom's bigger, make sure that for converges, it has to be a less than. For diverges, it has to be a greater than. So make sure you get the converges with the symbol right. Okay, this is true. This is going to be smaller. If my bottom is bigger, overall fraction is smaller. You could test some numbers too if you wanted. That's fine. So this is true. So when x is 3, it converges. So if this is true and my benchmark converges, then this guy converges. So this, when x is 3, it converges also. All right, so what all that means is I can go back to my interval, which I kind of knew halfway through the problem. This is going to be a bracket because 3 causes it to converge as well. Okay. All right, so let's try. I've got 2 more. We're running out of paper. Okay. Let's see, we did that guy. We got 2 more. All right, let's straighten this out. This camera keeps going in and out of focus. Okay, this is 6. Here we go. N equals 1 to infinity, n over 4n, and then times x plus 1 to the n. Okay. So this guy, what am I actually centered at? Okay, first of all, we know it's a power series because we've got the x in there, x to the n. But this time we're centered at, and remember, it has to be minus, so it's opposite. So we're centered at -1. Okay. All right, other than that, we do the ratio test. Let's see how this plays out. We do the ratio test, the limit as n approaches infinity of, we plug in n plus 1. I think I'm going to do n plus 1, and then I'm going to do x plus 1 to the n plus 1, and then over 4n plus 1, and then all over n x plus 1 to the n, and then over 4n. So I'm just going to kind of I'm going to put this in the numerator and then just stick that in the denominator. All right, the limit as n approaches infinity of n plus 1, we'll rewrite this, x plus 1 to the n, and then we've got an extra x plus 1 that's coming from there. And then we've got 4 to the n times 4, and then times the reciprocal. Plus 1 to the n. Okay. All right, so does anything cancel? Let's see. The 4 to the n's cancel. The x plus 1's to the n cancel. And I think that's it, but that, believe it or not, that makes a big difference. So we got the limit. Can we see? Okay. The limit as n approaches infinity, absolute value of n plus 1 times x plus 1. And then on the bottom, we just have 4n. So that's pretty good. That actually made a big difference. Okay, so we're just doing the limit on this part because this is the part that has the n's. This doesn't really have an impact. It's kind of like a constant almost, right? Because eventually x is going to be a number. And so because they're both to the first, my limit then is the lead coefficients, which is 1/4. So it's 1/4 x plus 1. That just tags along. Okay. And then ratio test says this has to be less than 1. If it equals 1, which is what makes this 0, we got to test those differently. Okay, so because it's less than, we can do -1 is less than 1/4 x plus 1, which is less than 1. Okay. So I'm going to multiply everything by 4. So I get -4 less than, here that cancels, so I got x plus 1 less than 4. Subtract a 1. And I get -5 less than x, which is less than 3. Okay, so that's my interval. That is my interval, except I don't know whether to put equals or not, because these make it 1, and the ratio test says I have no idea if the limit actually is 1. Okay, so, and we like to write interval notation anyways, so -5, 3, but I got to figure out what to put there. Also, remember we're centered at -1. Okay, and then I'm going 3, and I'm going 5. What is this distance? And it better be equal. Wait, make sure you guys can see. Okay, because this is fairly important. I'm centered at -1 because of that +1. Okay, and I'm going from, oh, okay, this is okay. I'm in the right spot. This should just be negative. Okay, so I'm going from -5 to 3. So this distance better be the same both ways, and that's my radius. And so that is 4. Notice this is -1. So from -1 to 3, that's 4. From -1 to 5, that's 4. So my radius is 4. And this is my interval. I just got to test -5 and 3. All right, so let's go at it. Let's do, I need that just for this first part. So let's do x equals 3. Summation n equals 1 to infinity, n over 4 to the n, and then I'm plugging in a 3. So 3 plus 1 to the n. Okay. So summation n equals 1 to infinity, n, and then this is 4 to the n, and it's because 3 plus 1 takes me to 4, and then it's over 4 to the n. Okay, so those cancel. Summation of n equals 1 to infinity, and that is n. Okay, as I add 1 plus 2 plus 3 plus 4 plus 5 plus 6, I don't think I'm going anywhere, right? It's just getting bigger and bigger and bigger. I'm not headed to any one specific number. Technically, we could do test for divergence. Test for divergence. Normally, we're looking for the limit as n approaches infinity of n. Normally, we're looking for it not to equal 0, right? As long as it doesn't equal 0, it diverges. Or technically, we say if it doesn't exist, which this is headed towards infinity. Okay, so this diverges. So all that's telling me is, and remember I did 3 first, I like to do the plus first if possible. This guy is a parenthesis instead of a bracket. Do it all over again for -5. Make sure, okay, I want to make sure you guys can see. X equals -5, summation, n equals 1 to infinity, n over 4 to the n, and then I'm plugging in, for x, I'm plugging in a -5. So -5 plus 1 to the n. Okay. All right, so what happens here? There's a couple ways we can clean this up. This turns out to be what? -4 to the n. Okay. So I can rewrite this. This I can rewrite as -1 to the n and then 4 to the n. So those cancel. Let's rewrite this. N equals 1 to infinity. I've got, oh, these cancel, right? So I have an alternating series and then times n. Okay. So what is going to happen here? I can do alternating series. I just focus in on this guy, right? And remember, how are we doing on space? Okay, my terms are supposed to always be decreasing. But if I do 1, and then I do 2, and then I do 3, they're doing the exact opposite. They're increasing. So this diverges. Okay, so if that diverges, all that's telling me is for -5, I get to put a parenthesis instead of a bracket. Okay, I already found my radius. I knew my interval. I just didn't know what was happening at the endpoints. Okay, last one. Oh, we're out of paper. Let's go grab some more. There's always more, people. There's always more. All right, here we go. Last problem, problem 7. It's actually pretty short. Summation n equals 1 to infinity. Make sure you guys can see. N factorial over 2x minus 1 to the n. All right, we know we have an x. This is a little bit harder to see what we are centered around because we do have this coefficient. So let's see how it plays out. We're still going to do the ratio test. What we could do here is factor out a 2. That would actually be okay. And I think we'll do that in just a minute. Ratio test. The limit as n approaches infinity of n plus 1 factorial over 2x minus 1 to the n plus 1 all over, and then this guy. We don't have a fraction, so that's at least kind of nice. We might want to take the time to rewrite it though, just so you visually see it. If you're okay, if you know what this cancels out to, you don't have to rewrite it. So this is n plus 1 factorial. This would be 2x minus 1 to the n, and then you have an extra 2x minus 1. And then you've got this guy. All right, so what cancels? These guys cancel. That's it though, right? So we have, oh, actually, how does this cancel? This actually can cancel a little bit, right? Because this is 5 times 4 times 3 times 2 times 1. This would be then like 6 times 5 times 4 times 3 times 2. So everything cancels except that biggest number. So this cancels to just an n plus 1. Okay. So because of the factorial, we're actually able to do a little simplifying. Okay, the limit as n approaches infinity of n plus 1 times 2x minus 1. Okay. All right. So what happens here? As this gets bigger, as this gets bigger and bigger, this is headed towards infinity. But okay, we saw one where it was all reals. Most of the time we're seeing it on an interval, but it can also happen when x equals a. Or another way to say that is when this equals 0. When this equals 0. So in this case, we would take this 2x minus 1. When does that equal 0? Okay, and it literally only happens for one value. It only happens when x is exactly 1/2. Okay, so we actually write that as our radius is 0. There is no interval at all. It is only when x equals 1/2. I have this notation, like the interval, but this is like set notation. So if that might be like that on WebAssign, because normally I would just write x equals, but this is like set notation for an interval, but it is literally just this one number. So don't let these parentheses scare you. That's just set notation. So when there's only one value, then they write it like that. And you can kind of see, I mean, really what happens is the summation is 0 because all these are actually 0. Because if you put in a 1/2 here, this goes to 0, which the whole thing goes to 0. So it's kind of a weird case, but technically when x is 1/2, the series does converge. It converges at 0 because you're adding 0 plus 0 plus 0 plus 0. But that's the way it works. Also, if we wanted to see this, like if we wanted to see, because technically we wrote it as only when x equals a, we could actually factor out a 2. Instead of setting it equal to 0, let me do it here. 2x minus 1. I'm going to take out a 2. And so then I would have x minus 1/2. And so here is my a, but remember I have to switch the sign. So a is actually 1/2. And so we said it was when x equals a. Okay, but I think it's just easier, especially when there's a coefficient, it's easier just to set that equal to 0. Okay, all right.